Now this right here is all about restrictions. What are the two restrictions on functions? They are, you cannot have a negative under an even radical, and you cannot have a zero in the what? You can't have a zero in the denominator. You can't divide by zero. Okay, those are your two restrictions. And so this problem right here does not even have a radical, does it? Nope. So I don't have to worry about there being a negative under the radical. But I do have a denominator. Okay? And so here's what I'm going to do. I'm going to take my denominator, x plus 1 times x minus 2, and I'm going to say it cannot equal 0. It can equal anything but what? 0. So I'm going to write x plus 1 cannot equal 0, and x minus 2 cannot equal 0. Now what do I need to do to solve each of those? Subtract 1 on both sides here, and so I have that x cannot equal negative 1, and I'm going to add 2 on both sides here, so I know that x cannot equal 2. Okay? So we know x cannot be negative 1 and x cannot be 2, but it can be anything other than those. Now let's read A. A says x can be any real number between negative 1 and positive 1. Well, we're saying it can be any number even outside of negative 1 and positive 1 as long as it's not negative 1 and it's not 2. So A is not correct. B says x can be any number, any real number. That's what this R is, real number. X can be any real number as long as x is bigger than or equal to 1. Well, we're saying the only two things it can't be is negative 1 and positive 2. It can be anything else. Well, that's not the same as what B or C are saying. Look at D. D says x can be any real number as long as x is not negative 1 and x is not positive 2. Well, that's your answer right there. Now, let's talk about this. If we have a function like this, 1 over x plus 1, our restriction is based on the fact that there is a fraction here, right? And we can't have a 0 in the fraction. So anytime you have a denominator, you just take what's in the denominator, x plus 1, and say that it cannot equal 0. Right? But now, what if my function was f of x equals the square root of x minus 2? Okay? What's under the radical has to be bigger than or equal to 0, doesn't it? Okay? So in this case, I'll just take whatever's under the radical and set it greater than or equal to 0. So now let me give you this is the basic rule. If you have a denominator, you take whatever's in the denominator and you say it cannot equal 0. And then you solve. Whenever you have a radical like this one, you take whatever's under the radical and you say it must be bigger than or equal to 0, because if it's smaller than 0, that's a negative number, and you can't take the square root of a negative. So as we look at this problem, the issue here is that I have two radicals. I have a radical on top and I have a radical on bottom. And I told you, I said you take whatever's in the radical, 15 minus x, and you say it must be bigger than or equal to 0, right? Now the radical on bottom, I take my x minus 7, and it can only be bigger than 0. It can't be equal to it because it's in the bottom of the fraction. And so now I just need to solve each of those. So I'm going to subtract 15 on both sides here. So I have negative x is greater than or equal to negative 15. And what do I do now? Divide by negative 1 on both sides. Since you divided by a negative, what happens to your inequality? So you say x must be less than or equal to 15. And let's solve the other one. I'll add 7 on both sides. And so I'm saying x must be greater than 7. And so our two restrictions are the following. X must be bigger than 7, or x must be smaller than or equal to 15. So we're saying x must be bigger than 7 or smaller than 15. X must be bigger than 7 or smaller than 15. Now in regular English, we're saying x must be between what?
15.
No, 7 and what? 15. So we got to figure out which of these means that. Okay, this one right here says x is any real number between -7 and 7. That's what this means. Well, we want it to be between 7 and positive what?
15.
So it's not that one. It's definitely not C, because all C excludes is -7 and positive 1. We want to exclude every number that's outside of -7 and 15, right? So it's not this one. Now, this one right here says x can be any real number as long as it's between 7 and what? 15. So that's your answer right there. So on this problem right here, we're not dealing with a denominator. We're dealing with a radical again. And I told you, anytime you have a radical, you take what's under the radical. So let's write what's under the radical. Everybody write x minus 3. And we know that x minus 3 must be bigger than or equal to what? 0. And so then I'll add 3 on both sides. And so x must be bigger than or equal to positive 3, right? And so let's look. This one says x can be any real number as long as x doesn't equal 3. Well, that's not what we're saying here, are we? We're saying it has to be bigger than or equal to 3. So it's not A. This one says x can be any real number as long as that number falls between -3 and positive 3. Well, we know that's wrong, don't we? Okay, but now look at this one. It says x can be any real number as long as x is bigger than or equal to what? 3, which is exactly what we have here, isn't it? Good. So that's the answer. So if it's a radical, you set the inside of the radical, whatever's inside the radical, greater than or equal to 0, right? If it's a fraction, you take whatever's in the bottom, and you say the bottom cannot equal what? 0. So if it's a radical, you say that what's under the radical must be greater than or equal to 0. If it's a fraction, you say what's in the bottom of the fraction cannot equal 0. So in this case, we have a fraction, don't we? Do you see any radicals? No. So I take what's in the bottom of the fraction, 9 minus 7x, and I know that 9 minus 7x cannot what? It cannot equal 0. And so now all I have to do is solve for x. So I'll subtract 9 on both sides. And so I have -7x cannot equal -9. And then I'll divide by -7 on both sides. And so I know x cannot equal, and -9 over -7 is 9/7. And so that's my domain. My domain is, we could say like this, x can be any real number as long as x does not equal 9/7, right? There's my domain right there.